Hello, Honors Algebra. Mr. Lawrence here with your review, your flipped lesson for Thursday, February 9th. We have a test tomorrow, as you may know, and we will be practicing to make sure that we know what's going on. Now, I know your homework assignment is a little bit long, 1 to 30, but remember, you're only supposed to do the problems that you need to do. And I thought at the end of this video, I'll even provide you with the solutions. That way you can check and see how you're doing on them. All right, first of all, let's talk about just a simple multiplying of monomials type problem. Say like 7x cubed y squared times 4, we'll make it negative x y to the 5th. All right, this is the first type of problem. I'll try to go quick through it because it should be really simple. First thing I'm going to do is I'm going to multiply my coefficients. What? Multiply my coefficients? Huh? My coefficients. Easy for me to say. All right. Now look, there's no reason for you in honors algebra to get this wrong anymore. Stop trying to remember and just get it right. You know that 7 times 4 is 28. So there's no way 7 times negative 4 could be 28. It's a different number. It's negative 28. Come on. Too easy, guys. Too easy. All right, next I'm going to multiply my x's, and it looks like I have an x cubed. I see I'm trying to find my floating tools. They're not showing up. Maybe I'll pause my video and look for them. Okay, I found my floating tools. I'll be using them shortly. All right, let me get the green highlighter. Now I'm going to multiply my x's. I have x cubed times x. Don't make a silly mistake here. X cubed means x times x times x. And then there's another x in the other quantity, so this is x to the 4th. The shortcut is to add the exponents, but a lot of you get shortcuts wrong. Don't use it if you're going to get it wrong. Think of how many x's are being multiplied all together. All right, and then finally, my y's. And there I have y squared times y to the 5th. Well, there's 2 y's here being multiplied, 5 more. Altogether, I have 7 y's being multiplied. All right, next type of problem, moving right along. Let's jump down to something a little bit uglier. Let's say we have 12x to the 4th, y to the negative 2nd, z. We'll raise that to the 3rd power, and we're going to put that over 16, x to the negative 1st, y, z to the 7th, and then we're going to multiply it by 9, x, y to the 5th, z to the negative 8th, over 3x, y, z to the negative 6th. And we will square that answer. All right, the first thing I'm going to do, I'm going to pretend like it's just one problem. I'm going to go ahead and start off in the first quantity. Pardon me, getting a little more music on here. Okay. I'm going to look in this first quantity, and I'm going to see 12 sixteenths. And I know that 12 sixteenths is going to reduce and turn into 3 fourths. Okay, I know this negative exponent is going to take him upstairs, causing me to have an x to the 5th in my numerator. All right, this negative exponent will cause him to go downstairs, causing me to have a y cubed in my denominator. These guys won't move, but these guys are like z over z times z times z times z times z times z times z. Those can cancel out, leaving 1 over 6 z's being multiplied, and that would be z to the 6th in the denominator. So this fraction on the left, I'll rewrite it so it doesn't look so ugly. Fraction on the left will turn into 3x to the 5th in my numerator. In my denominator, I'll have 4y cubed z to the 6th. Now the whole thing is cubed. And by the way, I'm going to slide a little negative in over here on the second quantity. I meant to do that. All right. Now I'm not going to do anything more with this at the moment. I'm going to go ahead and go to my second quantity. And again, I'm going to start with the coefficients. That'll turn into 3 over 1. The x's will simply just cancel each other out. There will be no x value in my second quantity. Y to the 5th over y to the 1st. That will simplify to y to the 4th in the numerator. This guy will go downstairs because of the negative exponent. This one will go upstairs. And so what I'll end up with is z to the 6th over z to the 8th. Now if I picture these z's in my mind, I've got 6 z's in my numerator 8 z's in my denominator, and I start to cancel them. Well, once I'm out of things to cancel, there are no z's left in the numerator. They're gone. And there's only 2 z's being multiplied in the denominator. So this turns into a z squared, but it's in the denominator. So this quantity in the numerator, I have a 3y to the 4th. In the denominator, I have a z squared. And it's to the negative second. All right, moving right along. Going back to the first quantity, I have to cube everything. And I don't know about you, but I think it's easier to cube this stuff after I've simplified inside. 3 cubed is 27. X to the 5th cubed is x to the 15th. How do I know? Because x to the 5th cubed means x to the 5th times x to the 5th times x to the 5th. That means there's 15 x's being multiplied. 4 cubed, 64. Y cubed cubed, well, that means I'd have a y cubed, and a y cubed. That would be y to the 9th. And then I'll have a z cubed. All right, that is being multiplied by this guy. Now in this one, I have a negative exponent on the quantity, so I'm going to have to flip my fraction and square it. All right, so this 3 becomes a 9, but he'll end up going downstairs because of that negative. Y to the 4th squared is going to be y to the 8th, and it'll be downstairs. Okay? The denominator has a z squared. When I square that, I'm going to get z to the 4th, but it will end up in the numerator. All right, I'm almost ready. I'm almost ready to multiply. Now, I'm going to look 4 different ways. I'm going to look this way, that way, and these ways to see if anything will cancel. I got to tell you that these 2 vertical ways should already be taken care of because I did the simplifying beforehand. So I'm going to look and see that 9 goes into 9 one time, goes into 27 3 times. All right, I've got a z cubed in the denominator with a z to the 4th in the numerator. That's going to leave me with a plain old z in the numerator. These y's will not cancel because they're both in the denominator. There's no division taking place there. I think I'm done canceling. So this will end up equaling, in my numerator, 3x to the 15th z over 64 y to the 17th. It's a long problem. All right, moving right along. Let me see here. We're going to talk about scientific notation really quick. All right, quickly we'll do a couple conversions. Excuse me, we're going to convert these to scientific notation. Remember to find my decimal point. It's located there, and obviously you see it here. I want my decimal point to be right after the first non-zero number. So for example, in the numerator, or it's not numerator, the top problem, I might want my decimal point to move between the 6 and the 2. First non-zero number is 6, then the decimal point. I would not put it here because that's after the second non-zero number. Okay, and remember, our answer in scientific notation will always be greater than or equal to 1, but less than 10. Okay, and 6.238 would be less than 10. So, to get there, I'm going to count my Scoopies. 1, 2, 3, 4, 5, 6. 6.238 times 10 to the 6. All right. Now, in this one, I want the decimal point to end up here. 1, 2, 3, 4. Right? 4.5 times 10 to the negative 4th. Okay. When I started with a big number like 6 million, my exponent was positive. When I started with a small number, a number less than 1, my exponent was negative. Okay, now going the other direction, going from scientific notation to standard is very similar. Hold on one second. Okay, so if we're in scientific notation, like 3.28 times 10 to the 5th power, or 4.16 times 10 to the negative 8th. All right. We want the decimal point to go to standard. We want it to be at the end of the number. 1, 2. Oh, excuse me. Silly me. Sorry. I misspoke there. We have to multiply the 3.28, or the 3 and 2800ths, by 10 to the 5th. That's what we have to do. All right? So each time I multiply by a 10, the decimal point is going to move one place to the right. So if I have 3.28 and then multiply by 10, I get 32.8 times 10 again, 328, 3,280, 32,800, and then 328,000. Now, how did I know to stop there? Well, notice my Scoopies. 1, 2, 3, 4, 5. And there's a 5 there. Okay, so my answer in standard notation is 328,000. Now with this one, I'm not multiplying by 10. I know it says multiply here, but when I'm multiplying by a negative 10, excuse me, a negative exponent, it's like multiplying by 1 over 10, or in other words, dividing by 10. So when I divide by 10, my decimal is going to get smaller. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. So it'll end up being, all these guys get filled in with zeros. 0, 2, 3, 4, 5, 6, 7, 4, 1, 6. And there you go. All right. Multiplying scientific notation is just like the earlier problem we did. You multiply the coefficients and then you multiply the bases of 10. So I'm not going to do a multiplication one, but I will do a subtraction one. Let's say we have 6.23 times 10 to the 3rd, and we're going to take away 4.81 times 10 to the 2nd. Okay. Now, right now, they're not like terms because the powers of 10 don't match. So I can't just go ahead and subtract. In fact, a lot of kids will do that and you'll get the wrong answer. And the OAA people know you're going to do that. Put that on there on purpose. I wanted this to be 4, didn't I? Excuse me. All right. So first thing I need to do is make my exponents match. And I'm going to turn this 3 into a 4. All right. Now, this got multiplied by 10, right? So this has to get divided by 10. Okay. That's going to slide my decimal point back 1. So my problem is really 0.623 times 10 to the 4th minus 4.8 times 10 to the 4th. And I just spread it out to give myself a little room. Now I know that this part here, this drives you guys crazy. You don't know how to handle this situation. Well, do you know how to handle this? Of course you do. Do you know how to handle this? Oops, wrong the symbol there. 3 minus 5. It's the same problem, except you get a negative answer. It's the same thing. So I can go ahead and rewrite this as a negative 4.800. In fact, I'm going to do this. I'm even going to move the negative onto the 0.623. I'm going to subtract, but when I do, I'm going to make sure that I get a negative answer because the 4 and 8/10 is bigger than the 6 and 23/100, or thousandths, excuse me. All right, so now I do my borrowing, right? That needs to be 10 because I can't do 0 minus 3, and that's not going to work. And I need to borrow here, so that's going to turn that into a 9. Well, I got to borrow there first, right? Okay, that ought to work. Okay, 10 minus 3 is 7. 9 minus 2 is 7. 7 minus 6 is 1. And then negative, and there is the answer. Okay, I don't want this video to go too long, so I'm going to do one more type of problem, well, two more types really. We need to do a graphing one and an a equals p quantity 1 plus or minus r to the power t. I'll do this one first. Let's say that you knew a bank, you were going to invest, I don't know, $5,000. The bank was going to give you a rate of 1.2%, and you were going to keep it in there for 3 years. Okay, how would you do a problem like this? Well, it'd be simple. All right, A would equal 5,000 times the quantity of 1. My money is going up, so it's going to be a positive 0.012 is my rate, because I always want the decimal, not the percent, and the time period is 3 years. Okay, I crunched that on a calculator, which I'll leave you to do, and you can see the answer. Now, let's pretend it's the end of my investment. It's today I have $8,000. Okay, it had been growing in a bank account. Well, let's do decreasing. It had been decreasing in a bank account. It's a bad investment at a rate of 3%. Okay, for 10 years. How much money did I put in the account 10 years ago? Well, I'm still going to use the same formula. Okay, today I have $8,000. My rate is 0.03, and my time is -10 because I'm going back in the past. All right, I'm going to go ahead and crunch that one so you can see my answer has to be that it goes up. All right, so let me clear that out. I have $8,000. 1 minus 0.03, and it's 10 years in the past. And there we go. So that means I had $10,848.57 in my account at that time. Okay, one last problem. This should be super duper simple. You guys are really good at this. And let me see here. I need a graph. And let's say I'm going to graph y equals 1/3 negative x plus 2. All right, hopefully most of you right now can see the asymptote, and the asymptote is going to be at the line y equals 2. So there's my asymptote right there. Where did I get it from? The plus 2 on the end. So my asymptote is y equals 2. All right. Now, remember we talked about what this negative exponent means. It means to use the reciprocal. So I could rewrite this equation as 3 to the power x plus 2. It might be easier to generate my t-table. I'm not going to use 3 in my t-table because when I go to plug in 3 for x, I'm going to get 27. Add 2, I'm going to get 29. It's not going to fit on my graph. So I'm going to go from 2, 1, 0, -1, and then -2. And we can even go with -3. Might not be necessary. All right, so when I do 3 squared, I get 9. I'm putting 2 in for x. 3 squared is 9 plus 2 is 11. 3 to the first is 3 plus 2 is 5. 3 to the 0 power is 1 plus 2 is 3. -1. 3 to the negative first is 1/3. So this will be 2 and 1/3. 3 to the negative second, 1/9. This will be 2 and 1/9. And you notice these numbers are getting closer to 2, but they won't ever get there. And I believe this is going to be 2 and 1/27. Okay, so I need 2 to the 11th, which isn't going to fit really well, but I can guesstimate it pretty good. I need 211, excuse me, not 2 to the 11th. I need 1, 5, 1, 2, 3, 4, 5, and then I need 0, 3, 1, 2, Yeah, 3. And then I had 2 1/3. And that's when they're going to start to hug. All right, so my graph is going to end up looking like this. And remember, it will never go vertical, and it never goes horizontal, and it doesn't actually touch that asymptote. It's closer and closer and closer. All right, this has been a longer video than normal, but it's a review video, so I will sign off and say good luck to you on your test tomorrow.